This is part 5 in Build Your Own SQLite series, and we are on stage 6. So far, we managed to query the database a little bit, print number of tables, print table names, count rows in a table, then read the data from tables, both single column and multiple columns. And now we are at this stage where we need to filter data before we print it. So the problem statement is we are given a query that looks like this: select something from some table, and there is a condition where color is yellow, or it can be anything. We need to do something similar to what we have done in stage 5 of retrieve data from multiple columns or single column. Or the number of columns at this point does not really matter. It's just that we are given this condition that we need to utilize in addition to fetching data. And the expected output is this. So we'll read the rows from table and we'll put it through some filter, something, and whatever comes out, we'll print that. Actually, the behavior is going to be, I don't think filter is the right word, but we'll get to that in a minute. So yeah, for now, you can assume that the contents of the table are small enough to fit inside the root page. We'll deal with tables that span multiple pages in the next stage. Right. I don't think this is going to be particularly challenging, this one. And these two, again, I don't know what is coming in stage 7 and 8, so I can't say for sure, but looks like we'll have to modify our code a little bit and also account for the fact that data is split across multiple pages. We can't just jump to one page and start reading. We'll also need to figure out how to chain through pages. So jump from page 1 to page 2, page 2 to 3, and so on and so forth. And then we'll need to retrieve data using index. This one I think is going to be a bit challenging. Yeah. So let's take a look at this one. What do we have? We have a way to load table rows, right? And these are the rows, and this is right after this step, I think we can filter the rows. Or maybe we can do that in load table rows function. I'm not sure right now. Let's figure it out. And everything else remains the same. Right. So let's figure out the... So I think first we also need to make some changes to our query parser, because now we have this additional thing to handle. So let's do that. Where's our parse select query function, right? So there is select, capture the list of columns, from capture the list of, capture the table name. And here we are going to have where, and we'll capture everything. So we'll call it filters, I think. Yeah, let's just call it filters. It will be everything after that, right? And this is, yeah, this whole thing is optional. This whole thing is optional. So I'll mark it so that we don't break other queries, because this thing won't match and then nothing will match. Right. So there might be additional spaces, one or more, then immediately followed by where, and then spaces, and then whatever comes after that will capture all of it. Okay. Now we have this. So we have our columns, and then we have our filters. So that is going to be match filters. I don't think there are going to be multiple conditions in this where clause. I think it is going to be just one, but the behavior of where is such that you can provide additional conditions using and or. So you can say were this and that, or were this or that. Let's just assume there's going to be only one condition. Otherwise, well, actually, if there are multiple conditions in these two other stages, we'll just get back to this, and instead of just instead of operating on this whole value as if it was just one filter, we'd split it on and or, and we'll figure out the priority of these operators, and we'll deal with it later. For now, I think we'll just say split it on empty space. Right. So we have this filter and we have an operator and arguments. So there is going to be this, this, and this, right? So this filters thing is going to have three elements. One is our column name, the other one is our operator, and third one is our value. And let me think about this. So our filter can be equals, not equals, less than, greater than, a bunch of other things that are supported. Let's do this. Let's say filter equals a dictionary, and we have equals as a filter, and this will be a function, filter equals, and let's create that function also. Filter equals right. This thing is going to receive, I think it is going to have, it is going to take column name. We need column name because otherwise we won't be able to match on these rows if we don't know which column to match on, and the value. So value, definitely we need value. Let's also keep column name for now, and we are going to return a filter function from here. This is going to accept a row, and this row is going to be a standard this data structure, this one, right? So here we are dealing with this. It's just a tuple, so we'll deal with it similarly. Right, where is it? So the row is a tuple, and now we need to figure out how to find the value of this column in a row. Right, so we can't use column name because the row does not contain the column name. We need to know what do we need to know? We need to know this information. Parse create table. We have parse select query, parse create table. Parse create table columns. So I think this one is going to receive in columns and row both. So columns will be a simple list of column name in order, and the row is going to be value 1, value 2, whatever. It will look something like this. That's what we're going to do. This is going to be only one column name, and so we can find Can we somehow give it the column index? So what are we trying to do? We have this parse select query, and this thing cannot have this information because if we put it after that, then we won't be able to use the information in this. We can duplicate it, but that does not make a lot of sense. There's something else there. Parse create table. Yeah, I think we don't have to do this this filters thing in this function. We can just return, I think, a list of all of these filters that we need to apply. And we'll give it column index also. That way we don't have to provide this information, the column list of columns. And so what we can do, what is this? Unresolved reference filter, filterequals, filterequals. Looks fine to me. Anyways, let's see. So then we'll just go ahead and say if row dot actually row column index dot, all of that is going to be binary bytes, not binary. So we'll decode that. Not equals let's make it a generator value. So now actually we don't need this column name. Yield row. All right. Unresolved reference. I know it's why is it saying unresolved reference? Anyway, and we return our function. Now what? Oh, nothing. I'm just going to ignore this for now. Right, so we have this filter equals, and that is registered in our filters map. So now we can say our filters is going to be actually our filter is going to be this. Right, so we'll return filter along with everything else. Now what? Shadows built-in name filter. Okay. Filters. Okay. Parse select query. Now we have this and we have filters. Right. Now so filters is also optional. So we can't just say we'll always find filters. We'll always have the key, but the value maybe none. So if the value is none, then we can do something like this. If match filters, else none, else empty list. Too many blank. Right, something like this. So if we don't have filters, then we'll return an empty list. If we have filters, then we'll return this thing, our operands and our operator. Right. So now we are down to this. We have filters. After rows, after we retrieve rows, and this load table rows is, so actually this one can also be a generator. We don't have to pull everything in memory all at once. But for now, let's focus on this. So we have some rows. Now we figure out if we need to move this below the function. That is ridiculous. Oh no, that is not ridiculous actually, because this is in global scope. So when the module loads, this code will be executed and the functions are then, function may not be available at that time. Right, so where were we? Here. Now we have filters, and we can simply say if filters, then the column index is going to be table columns dot index of our column name, and filter function is going to be our filter function that will be available at index 1, and the value is, let's collapse this and this and this. So we have this filter equals. So we'll call this, give it the value and the column index, and it will return another function that will be able to operate on the rows. So filter function is going to be, we'll just call it right here. We'll say filters value and column index. I will just rename that to something like this. Right, so we have filter function, and then we'll say rows equals filter function row for row in rows. Right, and similarly, we can have multiple of these filter functions, and we'll create a stack and put all of our rows through that stack. That way, we'll be able to extend this thing. We should be, at least. So we are calling this filter function. It is returning why is it returning okay, so that is a simple check. If the value is equal, then we return row, otherwise we return none, or don't return anything. That is same as returning none, right? So now we have these rows, and some of these values are none. And so we can remove all of these none values. We can use map, or I think this one looks more readable to me. I'm able to make sense of it immediately. Row for row in rows if not none. You can also do this using a map and none applicator. Right, so now we have these rows, Let's see. Then we pick these columns out of these available rows, and that should be it. Let's see. Let's select name color from Apple. The color is yellow. We don't get anything. Is it because of this? Let's print rows here, and let's print rows here. Okay, so the first one has rows and the second one is not, so that means our filter has some problems. Filter table column, this thing can't have any problem because any problem will just blow this whole thing up. The only problem here can be index error. So let's look at our filter function. I mean, this is also pretty trivial. The color equals yellow. Oh, because of quotes. Yeah, we can. Is it a good idea to unquote directly? Yeah, I mean, at this point, we don't have any knowledge of the type of the value. So we just need to either we implement that logic, either we implement something to figure out the data type of this column before we start applying our filters. That will be a bit too involved because then the sparse create table will need to parse and understand column types, all of these column types, and then we'll need to implement some kind of handling for each of these types. And there are so many types in SQLite. I just don't see any value in that. Instead, I think we can simply just say value is, what is that function for unquote? There is a function. Now I don't know, I don't remember the module or the library. Let me just look it up. Yeah, I don't think Python has that. I think I'm thinking about the function in Go. Go has a function for, I think it is in um, that package strcov. I don't know how to pronounce that. It has a function, two functions actually that can quote safely and unquote safely. I don't find anything similar in Python. Well, it does say something about urllib.parse and urllib dot quotes, quote and unquote. Yeah, urllib has urllib.parse.quote and urllib.parse.unquote. Yeah, no, don't want to deal with that. I think we can just say value dot replace single quote with empty value. And I think we want to do all. And I think by default it will replace all instances. And then we also want to let's take a look at replace. Returns max the number of occurrences to replace -1. The default value means okay, so by default it is going to replace all instances, right? So our value has been unquoted at this point. So this is, by the way, I don't recommend this because this is not safe. This is not safe in sense if your string is quoted with single quote and it has a double quote character some in the middle of it, all of that will be nuked. It just don't care. It does not understand the semantics of quotations. It is just blindly replacing everything. So don't do this. If you can help it, then try and implement or just use that URL lib thing. Or maybe there is something in Python that I'm not able to find in my, I think, 10-second of Google search. Maybe you'll be able to find something that is better than this, right? Cool, so let's try again. Ooh, okay, there is one result. And can we say, let's print everything. None type object has no attribute decode. I think it had ID. Yeah, it has ID, name, and color. I said ID, name, and color also, yeah. Okay, so there is a bug. What is the bug? None type object has no attribute decode. Each dot decode for each in values. Okay. I think there is a none value for column. I know which column. I think it is ID column. Let's go to 197 for each in values. If each is not none, else I don't think it supports else. List comprehension, does it support else? Else none. How about that? Yeah, it does not. So I'll say join each dot decode for each in values if each is not none. Each dot decode if each is not none, else none. Yeah, this will work. Actually, instead of none, we can use empty string. What if you remove the condition altogether? We don't have ID. Is it because the ID is the primary key and that is a row ID? And we are not reading row ID? I mean, we are reading row ID, but we are discarding everything. So this, I guess. What is it? This is load schema. Load header. Load table rows. Yeah, so this one is supposed to be row ID. How do we? We don't have to deal with this right away, but I would like to have it deal with the entire row. So this is a parse record. We can maybe convert this into a dictionary. Or actually, let's do this. Let's say row underscore ID and the rest of the thing. Right, so now we are returning, we are appending a tuple there. Load table rows, this is our only usage. So our rows RID and that for RID comma row, and then again RID and that for okay. Now we have rows for RID comma rows, each in rows. So we have access to row ID now. What can we do with that? Oh, so it is going to be a bit more complicated than that, yeah. Because now we need to figure out if we even need to print row ID. Yeah. That's why I should not give in to your impulses. All right. Looks good. Let's also check for red. Cool. So we have this. Also, let's, I think it is working without the where clause. Yeah, so we're not blowing anything up, right? Do we need to clean anything up? This is fine, fine, fine. I'll just keep this row ID right now. Maybe we might be able to use it later. Otherwise, I'll just clean it up. It's just a bunch of undos. Yeah, let's delete this. We don't need this. Cool. I think it is stage 6. Yeah. All right. Stage 6, test passed. Let's see. So what is next? Stage 7 is retrieve data using full table scan. Time to play with large amount of data. In this stage, you'll deal with same syntax as before, a query with a where clause. However, this time, the table you'll be querying will be larger and it will span multiple pages. Here's the tester. Here is how the tester will execute your program. Select ID, our name from superheroes. Well, eye color is pink eyes. Okay, so first of all, I notice ID immediately. Then our where condition is also, it's a simple equal sign, and we have already implemented that. There is no mention of other kind of conditions in where clause. I don't see at least. So I think we are fine with whatever we have. And here's the output it expects. Output is row ID and there's some, I know, stealth. Okay, something. The tester is going to use a sample database of superheroes that is 1 MB in size. You can download a small version of this to test locally. Read the sample database section in the README. You'll need to traverse a B tree in this stage. If you're unfamiliar with how B tree work, or just need a refresher, Vaidehi Joshi's Busying Oneself with B tree is a good place to start. For specifics on how SQLite stores B-tree on disk, read the B-tree page documentation section. All right. So I think we'll go through this B-tree pages documentation and also this link in our next video.